So what's given is the mass is 2 kilograms, the height is 60 meters, and I need to find potential and kinetic energy at the heights that they're given, like 40 meters, and so I have to find it somewhere at 40 meters, and the velocity at 40 meters as well, and then right before it hits the ground. So here would be the ground. So my potential energy is 2 G, and H is 60. That gives me 1200 joules. And my kinetic energy is 0 because there is no velocity yet before it gets dropped. So my total mechanical energy of the system is kinetic and potential energy together. And in this case, my total mechanical energy is 1200 joules. So no matter where I look in the motion of my object, I will always have the same energy, 1200 joules. So this number for potential and kinetic energy through the whole path is not going to change. So now I'm going to look right here. My potential energy. My potential energy is equal to mass, G, H is 40, so that gives me 800 joules. But my total energy must be equal to 1200 joules. That means my kinetic energy here is equal to 400 joules, because 400 joules and 800 joules will give me 1200 joules, and equals to 1/2 the mass and v squared. So if I solve this one for the velocity, I get velocity is equal to 20 meters per second. So I can use kinetic and potential energy, conservation of energy, to find the velocity sometimes. And if I wanted to find the velocity right there, the final velocity when it travels 20 meters, so I could use my final velocity is equal to the square root of 2gh, and I could find that my final velocity is equal to 20 meters per second. So I could use my old methods to solve for my final velocity, but I also can use it this way, conservation of energy. Then they ask you to find the potential and kinetic energy right before it hits the ground. So the potential energy before it hits the ground must be equal to 0 joules, because the height is going to be equal to 0. Then kinetic energy before it hits the ground must be equal to 1200 joules, because the total energy is conserved and must stay 1200 joules no matter where I look. So that equals to 1/2 the mass and v squared. That gives me velocity right before it hits the ground is going to be equal to the square root of 1200. If I take the square root of 100, that gives me 10, and 12 I can break into 4 and 3. The square root of 4 is 2, so the square root of 20 square roots of 3 meters per second. So the velocity before it hits the ground, the square root of 20, the square root of 3 meters per second. I could also use the final velocity the same as I did over here to find this final velocity before it hits the ground. But I can use conservation of energy and find my velocity by using conservation of energy. Here's another interesting example, number 57. A 1 kilogram ball is thrown into the air with initial velocity of 30 meters per second. What is the kinetic energy as it is being thrown? So the kinetic energy is equal to, one half mass velocity squared. So that is my formula that I have to remember, and equals to 1/2 the mass is 1 and the velocity squared is 30. So it gives me 1/2 of 900, which is 450 joules of energy. Because the total energy is conserved when the object gets all the way to the top, so let's say this is the ball, it's going to be thrown upward with initial velocity of 30 meters per second. When it reaches to the top, it stops for a second before it starts going down. So right here at the top, the velocity is going to be 0 meters per second. If the velocity is 0 meters per second all the way at the top, then its potential energy is equal to its maximum total energy, which is 450. So that means kinetic energy is all lost. Then the potential energy is maximum 450 joules. And the kinetic right there at the top is going to be, so this is initial, this is potential final. And it has initial energy right here when it's being thrown upward. So the potential energy at the top, so this is on the top, this is the bottom. So they ask you what is the kinetic potential energy as it reaches to the top. So that is potential kinetic energy at the top is equal to 0. So your total energy is 450. Your total energy is still 450 at the top as well, and it was 450 at the bottom. And how high does it go? Well, the potential energy is mgh. So your potential energy is mgh and equals to mass g height, and we just found that it equals to 450 joules. Then the height that it goes to is 45 meters. Again, nice way to use conservation of energy. So for number 58, very similar question. In this case, again, we have a ball. Its initial velocity is 10 meters per second. So initial velocity is 10 meters per second. That means it has kinetic energy initial equals to 1/2 the mass and v squared. So it looks like it's going to be 100 joules. And because it's all the way at the ground, its potential energy initial is 0 because it's mgh and h is equal to 0. So the total energy of your system in this case is 450 joules. So it doesn't matter where you look around in the motion of the object, it's always going to be 450 joules. So as the object reaches to the top, its final velocity on the top is going to be 0 meters per second. So the kinetic energy all the way at the top is going to be 0 joules, because that one is equal to 1/2 mass velocity squared, and there is no velocity at the top. That means the potential energy of the object must be 100 joules, because the total energy of the system must stay conserved and equal 450 joules. And if I use the formula mgh, I can find the height it went to. So I have 100, the mass, g, and h. So from here I see that the height it went to is 5 meters. So here is the next question. A coconut falls from 12 meters height. So you have 12 meters height right here. 12 meters. The mass of the coconut is given 2 kilograms. So I can find potential energy and kinetic energy of the object at this height, and I found that potential energy is 240 joules, and kinetic energy is 0 because it's about to start falling down from that tree. So the total mechanical energy of the system in this case is equal to 240 joules. Then it's about to hit a bystander who is 2 meters tall. So we started with 12 joules, 12 meters. It's about to hit the bystander. So I can calculate the potential energy of the coconut right before it hits the bystander. So the mass, G, and the height is 2. So that gives me 40 joules of energy. That means the kinetic energy at this height is equal to 200 joules, because the total energy of the system must be equal to 240 joules. And I can find the velocity if I want to, which is 1/2 the mass, v squared. So the velocity here is going to be the square root of 200, which is 10 square roots of 2 meters per second. Then they ask you, it rebounces up 0.2 meters above the bystander's head. So it goes 0.2 meters above bystander's head. So this is 2.2 meters. So, and they ask you to calculate, when the rebounds 0.22 meters, calculate the potential and kinetic energy. So the potential energy at that height is going to be the mass, G, and H is 2.2. So it looks like it is 44 joules of energy. That gives you kinetic energy. Oh, right at that height, it stops for a second. So the kinetic energy at that height is going to be equal to 0 joules of energy. It looks like we are coming to the new total energy now, because from now on it's going to be just 44 joules, because probably some of the energy got lost when it hit the guy in his head. So we have new total mechanical energy. Cannot look at the old one anymore. And then right before it lands on the ground, so right before it lands on the ground, now I have to use this new mechanical energy. So right before it lands on the ground, I'm going to have potential energy at this point is going to be equal to 0 joules. And the kinetic energy must be equal to 44 joules, because now it's been fallen down from this height, from 2.2 meters, and equals to 1/2 the mass and v squared. So it looks like my velocity here is going to be equal to the square root of 44 right before it hits the ground, or 2 square roots of 11 meters per second. Did not think I could fit my question into this window. So here it is. So here's number 60 question. the mass is given 60 kilogram, and the velocity goes from 5 meters per second to 10 meters per second. What is the kinetic energy of the bicyclist on his bike before it accelerates? So I have to calculate the kinetic energy initial, and that is 1/2 the mass v squared. So I have 1/2 60, velocity squared is 25. So it looks like it's gonna be 30 times 25, 750 joules. Then what is the kinetic energy of the bicyclist on his bike after that acceleration? So I have to find the final kinetic energy. So the kinetic energy final is equal to, again, 1/2 the mass mu velocity squared. So this one is final, this was initial, and equals to 1/2 the mass is 60, the velocity is 10 squared, and that gives me 3000 joules. And the next one is asking you how much work is done to increase the kinetic energy. The work is always change of energy. So the work can be equal to force times the distance if either one of those is known. In this case, it is not given. But I know that energy of the object is changed. If the energy changed, this is how much work was done. So now it is 3000 joules. It was used to be 750 joules. So that means the energy is equal to 3000 minus 750. And that is 2250. So this is how much joules of energy was put into the system. And the last one is, is it more work to speed up from 0 to 5, or is it more work from 5 to 10? So I need to figure out what was work. So this work from 5 to 10 meters per second. The work from 0 to 5 meters per second would be change of the energy between 0 and 5 meters per second. So the final would be 750 at 5 meters per second, right? Because we just found it right there. Minus initial when it was not moving. So you have 750 joules of energy or work. So in order to go from 0 to 5, you need 750 joules of energy. But in order to go from 5 to 10, you need additional to 2250 joules of energy. So there is more work to increase between 5 to 10 than it is between 0 and 5. So here's another question, number 66. 3 kilogram ball is at rest and is hit by a 1 kilogram ball moving at 4 meters per second. So I have initial velocity of first ball, 3 kilogram, which is 0, and I have initial velocity of the second one, which is 4 meters per second. And the final velocity after the first one gets hit by the second one becomes 2 meters per second. So I have to use conservation of momentum. Momentum before is equal to momentum after. So momentum before is going to be equal to the momentum after. Momentum before is the mass of the first one times its velocity, which was 0, plus the mass of the second one times its velocity, which was 4, equals to the mass of the first one, its new velocity, and the mass of the second one, that one final velocity. So I find that the final velocity of the second one is -2 meters per second. Now, what is the kinetic energy of each ball before the collision? So I'm gonna do, this was my A, this is gonna be my B. The kinetic energy of the first one, initial, is equal to 1/2 m1 v initial 1 squared, which is 0 joules because it was not moving. The kinetic energy of the second one, initial, is 1/2. Its mass is 1, and its velocity squared. So it looks like 8 joules of energy. Then for the next question, what is the kinetic energy after the collision of each? So C is going to be right. So the kinetic energy of the first one, final, is 1/2 its mass and its velocity squared. So its new velocity is 2 meters per second. So 2 squared gives me 6 joules of energy. And the kinetic energy of the second one, final, is equal to 1/2 its mass and its velocity squared. It's -2 squared, so I don't even have to put the negative because it's going to be squared. Gives me 2 joules of energy. Let me look at something interesting right here. The total energy before was 8 joules, and the total energy after is still 8 joules. If the energy is conserved during the collision, it's called elastic collision. So if the energy is conserved, it's going to be called elastic collision. And often they will ask you, is the collision elastic or inelastic? And in this case, because none of the energy was lost for anything else, this collision is going to be elastic. And then how much energy is transferred from one ball to another? So you used to have 0 joules of energy here, and now you have 6 joules of energy, right? So I used to have 0 joules of energy, and now you have 6 joules of energy. So the change of kinetic energy of the first ball is equal to 6 joules. Where did it get the energy from? It got it from the second ball. Because the second ball lost 6 joules of energy.